Good evening, all. Good evening, all. You are welcome to the tutorials with From Eternity, the Schoolboy. Today, we will take a look at Physics Assignment Review 4. So we'll see what we did in the assignment and make corrections. Alright, number 1 says, which of the following is not a fundamental SI unit? A, meter. B, ampere. C, Kelvin. D, radian. Chinwen, what's the answer? C is what? You say C? D, radian. Why did you choose D? How is it derived quantity? How is it derived quantity? Any idea? She knows the answer, but no reason for picking the answer. She doesn't know the reason why she picked the answer. Any idea? How is it deriving? Where is it derived from? All right, never mind. Other units. The first point is that other units here are what? Fundamental. Meter is fundamental. It's not derived from anywhere. Ampere is fundamental. Kelvin is what? Fundamental. Meter, temperature. Meter is length. Ampere is current. Kelvin is what? Temperature. But radian is just a measure of angle. Am I communicating? You know, in angle, we have degree, we have radian. Am I communicating? And it's actually what? Derived. It's actually what? Derived. By the time we go into some aspect of physics, you appreciate this. When we go into, even in mathematics too. Have you, in your calculator, have you noticed that in your calculator, you have radian there? There's a place you point, you will punch. There's a button you punch, it turns to what? Degree, from degree to what? Radian. These are different what? Measure units for what? Angle. Okay. The answer is what? D. Number 2. The length of a piece of a glass block was measured by means of a vernier caliper, as shown below. The length of the glass block is A, 1.63 cm, B, 1.64 cm, C, 1.65 cm, D, 1.66 cm. Michael, you have the diagram in your note, right? So what's the answer? You will not do it. You forgot how to do it. Choma, did you do it? But you were in class, right? You didn't come on Saturday. Success. You don't do it. Aloma. You didn't come on Saturday. Favor. How far? Wow. How come you know the answer? I don't know how to. That you what? So how did he arrive at 1.64 cm? How? Explain. No, it's not true. You have to explain it. How did you get from 1.64? Tell us how you got to 1.64. We want to know what you did.
I don't know how to explain this thing.
Try. Or you just go look for the answer and circle the answer. That's not what I mean.
I have to calculate it. Looking at this thing, there's how to count it. Then you get it.
Okay, let's do that. Okay, as we discussed when we treated this topic in measurement of length, we discussed vernier calipers. And we said that the vernier caliper has two scales, the main scale and the what? Vernier what? Scale. The main scale and the what? Vernier scale. And I said the calibration or the graduation may differ, but what matters is that we should look at the graduation and study it properly. The first thing to do is this. We are told that here is 1 and here is 2. And there is small divisions here. Normally these things are not to scale, they are just understand that these are small divisions. Am I communicating? Now, you should check the small division from between 1 and 2. That will tell you. Then write that number of divisions down. Then subtract these 2 from 1. You have 1. Then you divide it by this what? Division. To tell you what each of these represents. Am I communicating? Now, if you count 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 1. This is 1, 2, 3, 4, 2. Between here and here, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Am I communicating? Now, there are 10 divisions between 1 and 2. And if you subtract 2 from 1, you have 1. So you divide it by that division. Remember, here is in cm for what? Vernier what? Caliper. You divide that 1 cm by the 10 division, and you have what? 0.1 cm. What it means is that each of these, in this one is the main scale. See, this one below is the vernier scale. This one above this line, from outside here, is the what? Main scale. Now, in the main scale, each division is 0.11 cm. And in the vernier caliper, if you wherever the reading of the main scale stops at the graduation, surely before the what? The vernier scale starts. Am I completing? The reading of the main scale stops at the point, surely before where the vernier scale starts. If you watch that, the vernier scale starts here, right? Now, and judging by the fact that this is 0.1, here should be what? This is 1, right? This is 1.1, 1.2, 1.3, 1.4, 1.5, and 1.6. This is where the main scale stops. So the main scale stops here, and the reading of here for the main scale is what? 1.6. Am I completing? cm. Now, if you go to the vernier scale, you start reading the vernier scale from here. It is said that it was is a standard from this calculation now that the reading for the vernier scale, a calibration in the vernier scale is 10 division of one calibration in what? Main scale. Am I communicating? Now, that means since one calibration in main scale is what? 0.1 cm. Therefore, the calibration in the vernier scale is what? 0.1 cm times divided by what? 10 division, which is what? 0.01 what? Cm. So that means a division in this vernier scale is what? 0.01 what? Cm. And if you want to know where the reading of the vernier scale should stop is where the vernier scale coincides with the what? Main scale. So as you look at this, apart from knowing the value of this subdivision, trace where the vernier scale coincides with the what? Main scale. If you look, where did the vernier scale coincide with the main scale here? At where? 2, right? At this point. This is where it coincides with the what? Main scale. Then you started, remember that the vernier scale started from here, remember? So you start counting this subdivision. Just simply count the subdivision and multiply what you counted by what? 0.01. Or simply, since one division in the vernal scale is what? 0.01. That means here is what? 0.01 cm, right? Plus 0.2 cm, 0.03 cm. You stop at this coincidence, 0.04 cm. So that means the reading on the vernal scale is what? 0.04 cm. So if you now want to know the reading on the vernal caliper, you do what? You add the reading on the vernal scale to that of the what? Main scale to that of the what? Vernal scale. So the reading of this is what? 1.6 cm plus what? 0.04 cm. And this will give us what? 1.64 what? cm. So this is the reading on this what? Vernal caliper. This is the reading on this what? Vernal caliper. You got the answer, but you didn't get the explanation. I wonder how you could do that kind of thing, knowing an answer without knowing explanation. It's still a puzzle to me. It's so difficult for me to crack. How you know an answer? You cannot explain it. I don't understand that kind of thing. On a more serious note, I find it difficult to understand it. It's a miracle. It's a serious miracle that you know an answer, you cannot explain your answer. All right. If you know an answer without explanation, that is the one reason why you should do what? Research on that thing to know why is the answer. Simple. Okay. So the answer is B, 1.64 cm. Number 3 says, which of the following unit is equivalent to kilogram meter per second? Which of the following unit is equivalent to kilogram meter per second? Sussex. Okay, but did you cover the assignment? Michael, what's the answer? Huh? Chinwe, what's the answer? Huh? What's the answer? See, how is this C? Come here, come to the board and explain how it's C. Fast. Also. Fast. Come and explain how it's C. Fast now. No, there's no time. Oh yeah. Are you done? Oh yeah. What did you do? Oh yeah, explain. Oh yeah, now we're listening. You're back in the class. Stay like this so you can speak to the class. So what did you do? Can you hear her? Speak out so you can project your voice. Oh yeah. Okay.
And this kilogram per second is formula momentum. Momentum is mass times.
Formula or unit, which one?
Units.
Okay.
Momentum is mass times velocity. Velocity is displacement over time. Displacement is space. So mass.
Okay.
Is kilogram.
Agreed.
Is times seconds.
Okay.
So, units for NS is first Einstein.
Why did you jump to NS in the first place? What led it to NS? You jump from A, B, you jump to NS. That means you've seen the answer somewhere. You marker. Hello? See, if for this type of question, you don't just try to see. Jam can be confusing, okay? They can give you options that may look as if it's the answer, but it may not actually be what? Yes. Try to look at the other options. Don't just jump into one and start solving. Look at it. Look at the options. I expected her to start from A. Tell me why it's not what? A. By dismantling what the n Newton per watt second. Basically, she got the first thing to do is to look at what is this one all about. This kilogram meter per watt second. Now it's actually, as you say, mass times what? Velocity. I agree with that. That's why it's like it now. You now look for the options. The option A says, does anybody have a better idea? So let's not waste our time. Let's continue. Option A says n per watt second. N per watt second. Now, if you check, you see that n Newton is what? Newton is what? Force times what? Acceleration, which is what? Which is what? Sorry, Newton is mass times what? Acceleration, which is what? Which is what? Kilogram meter per second what? Square. But they said here, Newton, this is Newton, this one alone is Newton. Per second. That means you are still dividing it by what? Seconds. True of us. And you'll be getting something like this. kgms kilogram meter per second cube. Is it something with this thing? We are looking for kilogram meter per second. That's why it's not the answer. That's why option A is not what? The answer. Look at option B. Option B says Newton meter per second. What is it? Newton meter per watt second. Newton meter per second. If you split this Newton, meter per second on its own is what? Velocity, right? So they tell us that this thing is force times what? Velocity. Force times velocity is power. Okay? Is what? Power. So it's not, if you split this now, let's work with the unit. Unit of force alone is what? Kilogram watts. Kilogram watts. Mark, come here. Come and sit here. Newton is what? Kilogram. Good. Kilogram watt. Meter per watt second. Now it says Newton meter. So that means you are multiplying again by what? Meter per watt second. And you end up getting what? Kilogram meter square per second watt cube. It's still not the same thing with this thing. So the option B is not what? The answer. Now, C says Newton watt second. Newton watt second. Now, if you check this thing now, Newton is what? Kilogram meter per watt per second watt squared. Then times what? Seconds. Using law of indices. This will take care of one of these minus. You have what? Kilogram meter per second. It has the same what? Unit to what with this. You know, this momentum, this is also impulse. So that means impulse and momentum actually have the same what? Unit. Am I communicating? Good. Now, I'll take the answer, but let's look at the last one. It says joule per watt. Joule per watt seconds. If you look at the definition of what? Joule. It says, if you look at the definition of joule, it says joule is what? Force walk, right? Which is force times what? Distance. But it says joule per what? Second. That means times what? Second, right? This will take care of this. So seconds will do what? Sorry, this is the distance, sorry. Let's put it in what? Unit form. Force is what? Kilogram per meter per what? Second square. This is distance, sorry. D, not seconds. D is in what? Meter. Times what? Per second. If you check this now, this will give us kilogram meter times meter is what? Meter square. Per second square times per second is what? Per second what? Cube. Per second what? Cube. So this is not the answer. Have you seen how I dismantled all the what? Options. So that's why the answer is what? C. I expected her to come here and take this in step by step. The more we dismantle this unit, the more it becomes what? Part of us. But she just jumped and went to C and told us that it's NS. So that means she saw the answer somewhere and tried it, it worked. Any question on that? Any question on that? Any question on that? Mark, are you following? Huh? Are you sure? All right, let's go to number 4 question. Number 4 says, I, diameter of a small ball bearing, II, thickness of a piece of paper, III, diameter of a measuring cylinder, IV, length of a piece of wire. Which of the above can be measured using micrometer screw gauge? Option A says I, and IV only. B says I and II only. C says I and III only. D says I and IV only. What's the answer? From these things we listed, which one can we use to measure the which one can we use micrometer screw gauge to measure? Which are what and what? Thickness of a piece of paper and what? And what? Diameter of what? Diameter of what? Small bearing. Michael, what do you say? You said what? You said C. C is what? I and I. Length of a piece of wire. No.
Thickness of a piece of paper and diameter.
But you said C. Huh?
Sorry.
What's the option?
Thickness of a piece of
Is what?
I.
What did you write as I? The diameter of what? Measuring cylinder. No. Do you know what measuring cylinder is? It's not for macro. It's for smaller lengths, very small lengths. But you know what is measuring cylinder now in your lab? So it's not micrometer screw gauge you use there, okay? So I think the answer is what? Not I think, that's the answer. Diameter of a small ball bearing. You know what a small ball bearing is? That's what we are calling boilers when you are in your primary school. Who played with it that time? That time when we are small, we just get it from vehicles. We fix it we will get wood, fix it and sit on the wood. We go in. We use it as our car that time. We call it boilers, but it's actually ball was bearings. We call it boilers when we are small. These days now, you children don't play again now. Those days, we are always downstairs playing, building a lot of things. We go to mechanic, pick those things. Put it in wood. All right. So the answer is what? I and what? I agree with you. Number 5 says, which of the following are correct SI units? Which of the following are the correct SI units of the quantities involved indicated? If you check, there is, after a unit, you see the quantity in brackets. So they want us to know which of the following they are with the correct what? SI units. I says Newton. I says Newton. I says Newton. People are playing too much. Give her her notes. Or you come here. You are playing too much. Come here. Come this side. If you are playing too much. When you go to your house, no. Come here. You still migrate there and playing. Sit here. When you go to your house, you continue to play. Not here. Sit here. All right. So I, N, which is Newton, in bracket you see what? Force. I, you have Newton per meter, in bracket you see what? Torque, right? Then I, you have watts, in bracket you see what? Power. So which of them is correct? Before we go to the option, which of them is correct? Newton in bracket, is Newton the unit of force? So I is correct, right? So let's go to I, where you have Newton per meter. Is Newton per meter the unit of torque? What is even torque in the first place? What is torque in the first place? All right, let us not waste our time. You know, we have torque and the distance moments have the same what? It's the same force and distance, but the difference is that force in moment is in what? Distance is what? In linear form, right? I'm not calculating, but that of torque is a force that causes a body to do what? To do what? Rotate. Am I communicating? So is that force times that distance in that circular of what form? I'm angular from angular acceleration. Am I communicating? Good. Now, if that is the case, that basically whether it is angular or whatever it is, they have the same what? It's force times what? A distance is covered. True or false? Now, so but number 2 says that is Newton per meter, which is wrong. Which is what? Wrong. It should be Newton meter, right? Yeah. Good. Now, watt is what? The SI unit of power. Yes. Bless, now you following us. Are you with us? Is what the unit for power? So, if that is the case, that means the correct. Okay, look at the 4th one. Kilogram meter. Kilogram what? Meter per what? Second. So if you split this thing now, this is what? Mass, right? And this is what? Acceleration. That means mass times acceleration is what? Force. Force. The last one say force is the unit is force, but they put in the bracket momentum. Is it correct? So it's not correct. So the correct options here are I and what? I. So if you look at the options, the option that has I and I is what? Option D. Option D. So D is the answer. D is the what? The answer. Number 7 says state the dimensions of the following. I, impulse. B, acceleration. I, impulse. I, acceleration. I, work. I, impulse. I, acceleration. I, work. I what? Impulse. I is what? Acceleration. Then I is what? Is what? Work. Good. So who can state dimension of these three quantities? Who can do it for us perfectly? Who? If you can do it, come on. Don't waste our time if you can. Okay, maybe she will do one, others will. Let's take it one after the other. Be explaining as you are doing, so you don't waste time. Be explaining. We want to hear your voice, so. Huh? You say what? Continue. You say what? What do you say now? For formula, you enter the unit. Which one I say? Fast. Explain what you did. Please, our attention should be here. Please, let her explain what she did. From what? It's first as I hear. Continue. I agree with you. Speak out.
So the dimension is m raised to power minus 3.
How?
Mass.
I agree.
We have length.
Length is what? I agree with you.
Then time.
Time is so how many times are there?
3.
Count them. Let me see. So what is the relationship? Check what you did. Who correct her, please? She committed physical blunder here. How? This you did is for what?
This one. Point.
Who correct her? Who? So where did you take this time to? You threw it away. Who correct her, please? Who? Come. Come and correct her fast. Yeah, come. I say she come fast. Don't waste our time. Come. We arrive at that answer. Time is what? Okay. I will need someone that can do this thing on the board. Who? You come and do it. This from. Don't you have textbooks that you can look? Check this up. This is Monday. This thing was given on Saturday. It's a sign that you don't take this serious. That's the only thing I can explain about it. If you only come here and listen to class, you will not do your assignment. I don't understand it. Doing an assignment is not taking the answer. It's sitting down, bringing out your textbook. Go through this thing in your textbooks. We have done this in this class. Unfortunately, some of you we are not there. And if this is posted, shared, linked out there. Now I gave the assignment. If you watch, it keeps occurring in every assignment. I keep bringing it out. It's a sign that I don't know how to explain it. It is not encouraging at all. It's not encouraging. It dampens my spirits. I'll give assignment, you not do it. Then what are we doing? And I told you that in this tutorial, this is the most important thing here. If you can't do this now, then you are wasting your time, because you sit down and listen to me rap. I'll rap from 4 to 6 p.m. You go home without even grabbing anything. This thing is what you would, even if you don't know it, you can look it up, try to check it up and solve it. I don't like this. So it's not encouraging at all. It's not. I didn't call you out to start asking you questions spontaneously. No. This is what I just gave you to go home and do what? Work on it. Then what's going on? So what did you do? How did you arrive at that?
Impulse is equal to force times time. Then force is from acceleration, got to have that velocity over time. From velocity, we have distance over time. Then bringing it together, we have mass.
So what is the answer at the end? Per square. And we'll go. But if I do it, I'm not helping you. Nothing proves to just write on the board, solve it, tell you the answer and go my way. But if I do it, I'm not helping you. I am not. I'm not communicating. I am not. I will never deceive you. If I do it, I'm not helping you. There are things I expect you. I want you guys to appreciate this thing we are doing. If you go home, do your assignment, try to look it up. Study. Then how do you study? If you cannot do the assignment, that means you don't study. That's the meaning. Are you aware? That means you don't do what? I designed this in such a way that every day you have something serious to do, to study. That's how I designed it. But if you cannot do this assignment, then you don't study now. That's the meaning. And if you don't study, forget it. If you like, call a private teacher that will sit down for 20 hours teaching you everything. If you don't study, you remain the same. What matters is your personal efforts. Whatever we are doing here is to guide you. It's you that will make up your mind that this is what I want to achieve. Let me achieve this. And there's no time again. I thought you just come here, scatter this, and we'll go. But you're wasting time on it. I'm not happy about it. I must tell the truth. Let me solve this and let's go, please. All right. The impulses. Impulse is force times what? Times what? Time. Unit of force is kilogram meter per what? Second. And unit of time is what? Second. Law of this is S ratio of minus 2 times S is what? Is what? Minus what? Minus 1. So this is now what? Kilogram meter per second. Putting it in dimension is now equal to what? Kilogram is mass. Meter is length. S is time, T. So it's ml per T. This is the formula. This is the dimension of what? Impulse. This is the dimension of what? Impulse. Acceleration. Acceleration is from the definition of acceleration is what? Velocity over what? over what? Time. And velocity itself is what? Distance over what? Time. Over time for what? Acceleration, right? This will give us distance times what? True of us. Distance times what? Or let me take it step by step. From law of what? Fraction. This t will come up. We invert, right? You have distance over t what? Squared. Which is what? Distance per t what? Squared. The unit of distance is what? Meter, right? And the unit of time is what? Second. So meter per what? Second. Dimension for meter is capital L, which is what? This. Dimension for second is what? T. So dimension for acceleration is what? L per m, L per t squared. Dimension for acceleration is what? L per what? T squared. The last one says work. The last one says work. Work is, by definition, work is what? Force times what? Force times what? D, right? Good. Unit of force we know is kilogram per what? Per what? Basically, force is what? M what? A, right? Which is what? Kilogram per what? Per what? Kilogram meter per second square, right? This one is meter per second square. This one is what? Kilogram. Distance is what? Is what? Meter, right? M. So this times this. Remember what is there is times. Is now kilogram meter square. Kilogram meter square per what? S what? Squared. If you move this to what? Dimension. Kilogram turns to what? Capital what? M. M turns to what? Capital what? L. So we have L squared. S turns to what? Capital T. So we have T per T squared. So this is dimension for what? For work. Number 8 question says, which of the following instruments is suitable for making the most accurate measurements of internal diameter of a test tube? Which of the following instruments is suitable for making the most accurate measurements of the internal diameter of a test tube? A. Meter rule. B. A pair of calipers. Okay, now A says meter rule, B says a pair of calipers, C says a micrometer screw gauge, then D, tape rule. From the questionnaire, they say that instruments suitable for making accurate measurement of internal diameter of a test tube. Meter rule cannot measure it. Tape rule cannot measure it. The one that can measure it accurately is what? A pair of what? That's the one that can measure it what? Accurately. Not even micrometer screw gauge. Am I communicating? So the answer is what? B. Number 9. Which of the following is a derived quantity? Sorry, a derived unit. A. Meter rule. Sorry, meter. Sorry. We are talking about unit, not the instrument. Sorry. Which of the following is a derived unit? A. Meter. B. Coulomb. C. Kilogram. D. Second. Meter is unit for what? Length, and it's a fundamental what? Quantity. Coulomb is for charge. Charge is not a fundamental quantity. Charge depends on what? Time and what? Current. Charge depends on what? Time and what? Current. So it's not a fundamental quantity. C is kilogram. Kilogram is a fundamental quantity. D seconds. Seconds is a fundamental what? Not quantity, unit. Because kilogram is a unit for what? Mass. And mass is a fundamental quantity. Then D, second is for time. And time is a fundamental quantity. So the answer there is what? B, coulomb. So coulomb is a derived unit. Unit for what? Charge. Or quantity of what? Quantity of what? Electricity. Are we there? No worry. When we do current electricity, you understand that better. Now let's look at this. Let's look at this. The last question, number 10. Let's look at question number 10. This is a diagram of a micrometer screw gauge. Diagram of a what? Micrometer what? Screw gauge. It's 20, 15 what? 10. This is 0, 1, 2, 3. And what? This. Now, the question says, the diagram below represents a portion of a micrometer screw gauge. Full stop. What is its reading? Option A says 3.70 millimeter. B, 3.15 millimeter. C, 3.50 millimeter. D, 3.17 millimeter. Now, if you look at this thing now, when we discussed micrometer screw gauge, we also said that this has two scales. The vernier scale and the what? Main scale. Am I communicating? Good. If you take a look at one thing that I want you to understand is this. That this thing here, unlike in micrometer vernier caliper, the main scale is in what? 0. It's in cm. Here is in what? Millimeter. Milli what? Meter. Now they have already pointed giving you here as what? 0. Am I communicating? If here is 0, here is what? 1, 2, and 3. Am I communicating? Just as you have in vernier caliper, where the main scale stops, the calibration immediately before the vernier scale starts is where the main scale what? Stops. And that calibration is this one. Are we together? Is what? This one. So here is what? 1, 2, 3, and what? 4. Am I completing? So here this is 0, 1, 2, 3. So on the main scale, the reading is what? 3 watts. 3 watts millimeter. Now what happens next one is that on this scale now, how do we read this scale? As we have in the vernier caliper, where the main scale coincide with the what? Vernier scale, will give you the reading on the what? Vernier scale. Look at this place. Now if you watch, and here, what to check out is this line here for micrometer screw gauge. This one coincide with this. Are we together? Because you do the knob like this as you are checking the reading. It will stop here. So here is what? 15th division. It stopped at where? 15th what? Division. At this 15th division, what it means is this. A division here represents 0.01 watts millimeter. Are we together? 0.01 watts millimeter. For a vernier scale, a division here represents what? 0.01 watts millimeter. So if you multiply this is the 15th division. If you multiply it by this 0.015, 0.01, you get what? 0. What? 15 what? So this actually means what? On the linear scale, it means what? 0.15 what? Millimeter. Now, to get the reading on this micrometer screw gauge, you add what you got from where? Vernier scale to what you go for the main scale. So this is what? 3 plus what? 0.15. This gives us what? 3.15 what? Millimeter. So the reading on this micrometer screw gauge is what? 3.15 what? Millimeter. So the option, the most appropriate option there is what? B, which is what? 3 point what? B, 3 point what? 15 what? Millimeter. So this is the end of our physics review. Let's put our whole chest in this review. You may not understand what I'm doing now, but I just pray that when you understand it, that it will not be too late for me to take my time and be copying this on the board. You think it's something serious. So why didn't I snap it and send on WhatsApp? I have a WhatsApp group, right? But why didn't I snap it and do what? Send it. I want you to copy it right in your notes. That's why I cool down and copy it on the board. I want to copy it in your notes. Go back, do it, research on it, do it. Come to class, discuss it. If there's anywhere you made a mistake, then you correct it. When you want to study, you open your notes and go through it and study it again. If I post on WhatsApp, you will not copy it, and it will remain there. Your phone will have issue, and it will do what? Disappear. But if you have a good note, the note I used when I wrote my JAMB, one of my students, those of set of 2021 set, 2021 set, my JAMB student, 2021 set, one of them seized it. As at that time, this a note I used for close to going to how many years? Up to 16 years ago. As at that time, carried in my house. Because I knew the importance of having a comprehensive note. I don't joke with it. She seized it. She says she should give me. I know she will not give me again. I just left her. The most important thing is let her pass. What am I saying? Take this in seriously. Don't just do anything anyhow. Just do it. I'll be here talking some. No, won't even put anything down. No. That's wrong. Take it seriously. This is studies too. Take it seriously. I encourage you to do that, and you will not regret it. All right. Thank you very much. Do you have any question? Any question? Any question? All right. Thank you very much for your attention. God bless you.